Right, good afternoon everybody and welcome to this talk on LPCXpresso. My name's Andy Beeson and I am one of the developers of LPCXpresso within CodeRed Technologies, and I'm here today to present to you in collaboration with my associate David Donley here from NXP, and also a colleague from CodeRed, Derek Morris, sat down here in the corner. Now, the actual presentation we're doing today is going to fall into several sections. So first of all, we're going to give you a little bit of background information about NXP's MCUs. We're going to talk a little bit about the LPCXpresso hardware and the various items within that. And then I'm going to give a demonstration of the LPCXpresso IDE. So talking both about project creation and debugging projects as well. Sure. I've then got a little bit of information about CodeRed's full product called Red Suite, and also a little bit of information on some of the hardware products that we offer. So that's a little bit of background about what we're going to be covering. What I will do now is hand over to David, who will start the main flow of the presentation.
Hello everybody, I'm David Donley. What is LPCXpresso? A lot of people have heard of LPCXpresso, and some of you are new to the platform. LPCXpresso is a prototyping and development platform for NXP MCUs. There's a number of different components that make up this platform. One of the pieces is NXP. We produce the MCUs for LPCXpresso. There's 3 different LPCXpresso boards that are available today. One with a Cortex M0 and then 2 Cortex M3 parts. I'll talk about those more specifically later. Another one of the partners in LPCXpresso is Embedded Artists. Embedded Artists not only makes the LPCXpresso boards, but they also make a base board as well as a prototyping board that you can use for expansion. Also, a big partner is CodeRed Technologies. They do the LPCXpresso software and drivers. The LPCXpresso software it's an enhanced version of Eclipse, and today we will show you how to use it and some of the ways that it's been enhanced. One of the important things is the LPCXpresso IDE is free of charge, up to 128K of code space, but if you need to go beyond that, there's a number of expansion options. And then finally, the last component of the LPCXpresso development tool ecosystem is you guys and your imaginations and your products. NXP offers the complete ARM portfolio. They start at ARM 7, they go through ARM 9, and they also offer M0, M3, and M4. M0 is a new core from ARM that is extremely low power and extremely low cost. M4 is a core that has a DSP functionality. NXP was first to market with microcontroller products with both M0 and also first to market with M4. NXP is a leader in ARM flash MCUs. A long time ago, our background was in 8051. Then we came out with the LPC 2000 family. This is probably one of the first ARM 7 parts with flash built in that really made the market take off in this small embedded space. And then we've moved all the way up to the LPC 4000 today, where we offer the Cortex M4. Our strategy going forward is 100% focus on ARM. So if you work with NXP, you will find that there is a lot of compatibility among the different products because we have an ARM-based portfolio. There's a lot of third-party vendors that make tools, and you will find that because we focus on ARM, that it'll be easiest to use our products. Some microcontroller vendors, to cover the entire application space, they need a lot of different architectures, and that just makes things more difficult for you. This shows the basically the application space that NXP is covering today. At the very low end in the 8-bit world, there's parts that are 6 and 8 pins. NXP doesn't have any equivalent products to that today. However, we do have Cortex M0, which meet current consumption, space, as well as cost that you could see in some of the 8-bit products. And then at the high end, we move into the Cortex-M4, which has a DSP functionality, but we're not going all the way up to the ARM application processors today to do like high-speed application execution devices like tablet PCs. So our main focus is on the embedded space, but that typically used to be called, 816 32-bit embedded space. The continuum of products offered by NXP today are Cortex-M0. This is definitely at the lowest end. Cost for these parts in 10K quantity resale, we have a part that actually goes for 65 cents down here. Moving up, there's a ARM7. You're starting to see fewer ARM7 products come out. NXP, right now, all the new products we come out with are Cortex-based. The Cortex M3 will offer you more performance, and it also generally costs less than an equivalent ARM7 part. Recently, we've come out with the Cortex M4. All of these Cortex parts are compatible. So if you have Cortex M0 code, you can run that on an M3 or an M4. So this makes it easy if you are using these products to move up and down between them. So this is a little bit about LPCXpresso. LPCXpresso is a board that it costs $29 US dollars, and half of it is a debugger, and then half of it is actually a target portion that contains an NXP microcontroller. So there's 3 different variations of this board today. There's an 1114, which is a Cortex M0, and a 1343, which is a very similar part, but with a Cortex M3 core instead of an M0. And then finally a 1768, which is a much higher end product than those two. The 1768 includes Ethernet and 512K flash, and it runs at 120 megahertz. So that's actually one thing I'd like to point out. Currently, the LPCXpresso has a 1768 on it, where the next build will have 1769, so that will bring it from 100 megahertz to 120 megahertz. The I/O on this board, it consists of a single user accessible LED and a bunch of 0.1-inch header pins. So this is really meant to be the starting point for something else. Out of the box, you can blink this LED, or you can run the debugger on it, but there's not, like, you can't really control a motor or anything because there's not a lot of external circuitry. However, we remedy that with the partnership with Embedded Artists. The first thing I'd like to point out from Embedded Artists is the LPCXpresso Proto board. This contains many footprints for different types of surface mount boards, and it also has 0.1-inch through-hole connections for mounting components. There's also an Embedded Artist base board that has many components already mounted on it, and they have really good examples they distribute with it. When you buy the LPCXpresso board with the debugger, that comes with a coupon that gets you discounts on the base boards from Embedded Artists. Here's a photo of the Embedded Artist base board. It has so many peripherals, it's almost too many to list. It's a good deal if you're looking for something to get you started so you can run code that does more than blink an LED. This is a really good board to consider. Now I will turn the presentation over to Andy.
Thanks, David. So there's a few seats around. You guys want to come and sit down?
You can sit up here.
Yeah. No, leave it 2 seconds. Yeah. So David's taken us through the hardware side of LPCXpresso. We're going to start now looking at the actual software side, so the software development. So where CodeRed comes from is basically we take open source tools and add value to them. So LPCXpresso is based on the open source Eclipse IDE, to which we've added a number of extensions, some of which we'll come across during the demonstration in a minute. We take the GNU compilation tools, which from benchmarks done by a large variety of people are easily on par with some of the rather expensive compilation tools you can buy. We take the GDB debugger, We've got C libraries, so both the open source newlib and also our embedded focused own C library called redlib, and then various other tools associated with actually building your application to produce the LPCXpresso product. So if you've got the IDE, you can basically debug targets via the LPC link, so the LPCXpresso board David has just described. You can debug through our own RedProbe product, which is another equivalent product, if you like, with higher performance that we'll talk about later on. And we can also plug directly into a development board that CodeRed develops called the RDB 1768, which has got its own debug connection as well. So when you actually go off, you download LPCXpresso IDE from our website, and it basically delivers you a single executable which gives you an installer that installs absolutely everything that you need all in one go onto your machine. As part of that installation, we don't actually do anything to modify your user's environment beyond effectively installing the drivers. So there's no path modifications made, we don't modify the registry, and this means that we can actually have multiple non-interfering installations of the tools. So if you've got version X of LPCXpresso installed on your machine and version Y comes out, you can quite happily have both installed in parallel, and you can use that as a means of evaluating the next version before you actually move your full product development over. With regards to the actual platforms that we support Windows, so XP, Vista and Windows 7. And we've also, in the last month or so, released the Linux version of our product, which runs basically on Ubuntu and Fedora. And we know through the LPCXpresso forums, which I'll cover a bit more detail later on, that there are users out there using other platforms such as OpenSUSE. So basically, we've got a wide range of platforms that we can actually run the tools on. Now what I'm going to do now is move over to actually start demonstrating those tools in action, and we're going to be doing that on a Ubuntu box. So if you just give me 1 second to swap machines over. And what I'm going to do is start LPCXpresso, so I've just got a shortcut on my desktop. So I shall start that up. And the first thing that Xpresso will actually do is ask us to select a workspace. So what a workspace is basically it's a directory, to all intents and purposes, that contains a set of projects, where each project is effectively, say, an application or a library that we're currently working on. So we can have multiple workspaces existing on our machine, each with multiple projects, but each instance of LPCXpresso will only be connected, if you like, to one workspace at any one time. So in this particular case, I've got a workspace being displayed for me, and that's the one I'm actually going to launch. So I shall click OK, and LPCXpresso will then carry on starting up and open us up into that particular workspace. So by default, when we actually start up LPCXpresso, we end up with a screen with a layout known as the developer perspective. So a perspective in Eclipse terms is the layout of our various windows or views within the IDE. So the developer perspective is the whole thing, and then each of the views that we've got, so we've got 3 views here, tabbed along there, we've got another view here. These are the views within the perspective. So what I'm going to do first of all is just take us through what the various views I've got displayed here actually are. So on the left hand side over here we have the Project Explorer view. So this is the view that gives us the details of what projects exist in this current workspace. And in the workspace I've actually got here, I have 3 projects. So the CMSys V1P30, this library here, and then an application program called SysTickTwinkle. So that's my Project Explorer. I can open each of those up, and by clicking on the arrow, and actually look at what contents each of those projects contains. So in this case of SysTickTwinkle, we've got 2 source files, CR Startup LPC13 and SysTickTwinkle. I can just simply double click on one of those, and it will launch that source file into the editor view, which is the big one we've got over here on the right hand side. So the editor view is basically where, surprisingly enough, we edit our files. Again, it can be tabbed, so I can actually launch more than one source file, and each one will appear in its own tab. It's then quite possible, if I want, to relay out the screen slightly, so I can drag that tab over to the right hand side, and it will basically put that into its own tabbed view within the editor view. I can do the same here, so I can drag that one down if I want to. And basically you can mess things around as much as you want. So in a similar sort of way, I can actually drag other views within the perspective around. So if I take this view here, which is core registers, which is a view we'll look at when we start debugging later on, I can drag that over to there, and again we've relayed out the screen, and I can effectively do this ad infinitum if I want. You can obviously see that if you're not careful, things can get a little bit messy though. So there's a very quick solution to that. If I go up to the Develop Perspective tab up on the right hand side and right click, there is a reset button, and that will put everything back into the layout it was originally, apart from the editor view where I just need to drag them myself. Okay, so I mentioned the editor view being effectively where we edit our files. The editor within Eclipse is actually a fairly powerful one. So there's actually a lot of functionality in here that you'd expect maybe from other IDEs you've used in the past. So one example, for example, is if I right click here, I can turn on source level folding, if I can move my mouse far enough. And that then allows us to basically close up or expand each of the functions, for example, so that all I see in this case when I close down main is the main function itself. And then if I want to, I can just reopen it back up again. There's also quite a lot of things like editor templates and code completion. So if I go into my code up here, and let's say I know the name of the function I want to enter begins with GPIO. If I then hit Control Space, it will actually give me a list of all of the functions that have been found by the indexer which start with GPIO. I can then go and select the one that I'm interested in, let's say that one, and it will then insert the name of that function in there for me. Now I've typed that function in, but obviously there are some parameters there, so if I Control Shift Space on that, it will then tell me what parameters that function actually expects, so I can go and type them in as required. Other neat things are things like, rather than bringing that list of the functions up, I can just use Alt and the / icon, and it'll actually just toggle through each of those various labels that it's found until I find the one I'm actually interested in, and then I can stop, obviously, at that point there. Yes, sir?
So you mentioned that Code Red enhanced Eclipse. So which of these features are...
So the editor we're talking about at the moment is basically standard Eclipse functionality. As I go through, I will pull out the bits that we have added. Okay? Other things that you can do are things like if we use Control and the / button, it will insert a comment automatically, like that, and we can do that similarly for a whole block of text if we actually go and highlight it. So again, you can see the whole block being expanded, commented in or out as I press the Control and the / button. You can see obviously on the screen that we've got a fair amount of context sensitive colouring going on. Other neat things, for example, if I double click just after an opening bracket, it will actually select all of the code until it gets to the closing bracket. Similarly, if I click on the closing bracket, you can actually see that it's highlighted, hopefully. So trust me, that has got a little square around it that you can't see on the projector. That's actually telling me where the opposing brace is. So it's basically trying to make editing as simple as possible for you. So that's the editor, and as I said, that's basically standard Eclipse functionality. Okay, So one other neat feature I was going to say about here is, let's say I go and add a function call in here. Let's just call GPIO init again. Obviously I wouldn't do that in a real case, but that's nice and simple. Save that. If I now right click over the file on the right hand side, I'm not quite sure. Why is my mouse doing that? I don't want to move it. So I'm expecting a context sensitive menu at this point. There we go. Thank you. I can go and compare with the files in my local history. So in this case here, there are effectively two files in there. Excludes the times, I'm actually on UK time still. And in this case here, it's done a compare, and right, I'm comparing it against itself. So now I do a compare against the original file. You can actually see that it's highlighting the change in the actual source code that's been made. So it's quite a neat feature. Again, standard in Eclipse though. Okay. What isn't standard in Eclipse though is this big panel that we've got over here called the Quick Start panel. Now, one of the things that we were trying to do in the enhancements we've actually made to Eclipse is to make the product as easy to use as possible. And Eclipse has got a huge amount of flexibility, but it also means it's quite confusing to get started with using, and there's a lot of configurability that you'd have to go and actually work out for yourself in many cases. So what we've done is try to pull some of the most commonly used bits of functionality that users need to do and put them onto what we call the Quick Start panel. So some of the Quick Start panel entries are effectively standard Eclipse functionality. Some of them are the enhancements that we've actually made ourselves. So we've actually got a number of different elements within the Quick Start panel. So if I just untick the start here, we've basically got start here, which is, if you like, the most commonly used bits of functionality. And the things that are in the start here item also actually exist along with other options in the various other entries within the Quick Start panel. So we've got a set of things related to projects and file wizards. So creating new projects, creating library projects and so on. We've got various bits of importing and exporting. So this allows us to import example projects, export the projects that we're working on and provide them to a colleague, for example, if you're not using version control. We've got various items related to building, so actually creating our projects and turning them into an application. We've got various items related to debug, and then a few extras. Okay, but as I said, the one that opens up by default and is probably the most useful is the Start Here icon. And amongst the things that we actually have in there are the things that most people will use straight out of the box, which are creating a new project and importing example projects. Okay, so I'll come back and actually go through how we use those in a minute. And certainly in the case of the new project, that is one of the big areas of functionality that we've added, in basically adding wizards to create code bases for an exact MCU that you're using. So I'm going to minimize that panel. So again, there's a standard bit of Eclipse functionality. If I double click on a view, it basically fills the screen. So that's quite useful when you're editing source files, for example, because you can quickly go and double click on it, edit in the full screen mode, or pseudo it full screen mode, and then double click on it again to decrease it back to the standard view. So the final corner, if you like, of the standard develop perspective is the one down the bottom right down here, which is normally a bit smaller than that. So again, I'll just drag it down and decrease it in size. And from a build point of view, the two important things that we've got in this window are the console view, which is where our build log will appear. So when we do a build, that's where we get the information about what's going on. And also the problems view, which basically lists all the errors and warnings that may be encountered during our build, so we can actually find them and go off and correct them. Okay. So that's the final part of the view. The other thing that we can see down here in the right hand corner is some status bar information. So does that actually show up? Just about. So first of all, we've got the name of the project. So in this case, it's LPCXpresso Cystic Twinkle. And so that's the project that I've currently got selected. If I click on that, it will open up a file browser, so we can actually go and look at the files directly in an Explorer window. If I control click on that, it will open up a terminal window onto that. So again, these are quite useful in particular circumstances. So perhaps we want to go and run a command line tool straight off without going through the IDE. That opens a window into the right place for us with all the tools set up. I've also down here got, if you see NXP LPC 1443, so obviously NXP is the MCU tool vendor. This is LPCXpresso, that's whose MCUs we're talking about. And the LPC 1343 is the specific MCU that we're going to generate this application for. So that means that the options within the compiler, linker assembler, linker script are all set up for that particular MCU. Now I can go and click on that, and if I was on the internet, that would take me off into the file browser that gets launched within Eclipse. It's not a file browser. Web browser, thank you. And so we can actually take us off to the NXP website, to their documentation pages, so we can go and get the data sheet or the user manual for that part if we want to. Or alternatively, if I can control click on that, it will actually open up the project properties for this particular project, and I'll come back and talk a little bit more about project properties in the moment, but this is basically where we tweak the compiler options that are going to get used, and potentially we could even change the MCU if we wanted to. But those are just some quick links down at the bottom. Now I mentioned that when we launch LPCXpresso, we start up in a specific workspace that we choose. Now sometimes you're obviously going to want to start using a different workspace. Now, obviously I could close down LPCXpresso, start it back up, but I can also do that in a more automated way by switching workspace within the actual LPCXpresso product itself. So what I'm going to do is I'm going to create a completely fresh workspace. So I think it's what, 415 or thereabouts today, so we'll just call it demo 415 and launch that. And basically that's closed down the existing workspace, so closed all the files, and it's now creating us a completely fresh workspace from where we're going to carry on in this demo. So you can see in this case that the Project Explorer view is blank, so we've got no files in there at all. Right, so I shall just close down the welcome and maximise my screen. So this effectively is the position that you will find yourselves in if you download LPCXpresso and start using it from scratch. You've got a blank canvas to start your work from. So where should you go next? Well, the first thing I would always recommend doing is actually going and importing some of the example projects. So we can do that from the Quick Start panel. So I go and click on Import Projects. And we then get two options. We can either browse effectively the disk, so it'll go and browse the examples directory within your installation, or again, if I was connected to the web, I could go and browse the web, and that button would take us off to the downloads page, the examples downloads page that's on NXP's website, and we could then download, say, updated versions of the examples if we wanted to. But today we'll just click on Browse. And that takes me into a directory where I can basically choose which MCU I want to import examples for. Now in this case, the board that I'm going to be using is an LPCXpresso 1343, so it looks just like the one in the picture that David showed you earlier on, and looks, I think, identical to the ones that you're going to get at the end of the presentation. So that's an LPC 1000 family. It's a 13XX, and inside here I actually have 3 zip files, so all of the examples are delivered in zipped format. So if I start at the bottom, in this particular version of the tools, the LPCXpresso 1343.zip file is a basic set of examples which basically use the hardware that's on the board on its own. So They are effectively variations on Blinky, okay? Because you can't exactly do a lot, okay? But it's a nice simple place to start. We then have the next project up, which is in this case called Examples LPC13XX, which is NXP's examples for LPCXpresso. So this actually contains rather a lot more source code for you to go away and look at, that actually uses a lot more of the peripherals than one GPIO bit, which the other examples use. So the first zip file is quite useful to get you started if you just want a quick play, but once you actually get a bit more advanced, it's this one here you want to start looking at. Okay. The final zip file is this thing called CMSIS. Now, CMSIS stands for the Cortex Microcontroller Software Interface Standard, which is effectively a software standard that's been developed by ARM in collaboration with MCU vendors and tool vendors, such as NXP and Code Red. And effectively, it provides a means of delivering header files that define the peripherals that are available in a particular MCU. It provides header files and source code related to functionality in the Cortex microcontroller itself, and various other small bits of functionality like that. Now, with most projects that you will develop under LPCXpresso, most people use CMSIS. So when you start a new workspace, it's always a good idea to go into the examples and import that CMSIS project that we've got up here. Okay? Otherwise, you can find the project wizard, as I'll show you in a minute, giving you an error to say that that project doesn't actually exist in your workspace at the current time. So what I'm going to do now is import some examples, and I'm just going to import a couple from that basic set. So there's various examples within that zip file. I'm just going to import, first of all, the CMSIS project. There's a library, lpc13xx.lib, which basically contains some code for accessing the GPIO and timers, and which is used commonly by various others of the examples. And then I'm going to import a couple of Blinky projects, so SysTick and SysTick Twinkle. So I've selected the projects I want to import. I click on Finish. Excuse me. No, okay, yeah. And those projects have now imported. So just close those up for a second. So you can see that the actual project import process is quite simple. But let's say I actually want to go away and create a new project myself. So again, I go to the Quick Start panel and click on New Project. And I'm given a number of MCUs that I can actually select from. So what you need to do is go and select the MCU that you want to use. So in this case, we're using an LPC13. Okay, and I then am given a choice of two separate project wizards that I can actually run. So we can see NXP LPC1300C project and LPC1300 semi-hosting C project. So what is the difference between these two things? Well, inside LPCXpresso, the C libraries basically have a number of different variants. So a variant is basically talking about what sits at the bottom end of the C library. So with a semi-hosting C project, functionality that requires I/O, like printf or scanf, where you basically need a keyboard or a screen for that input-output. With semi-hosting, we can actually use the input and output functionalities of our host PC via the debug link. So in other words, if I create a semi-hosting project and I do a printf, that printf code will basically squirt my string up my USB cable into the PC, and the PC will display it down here in the console window. So I'll actually show an example of that being done a little bit later in the presentation. Okay. The downside with using semi-hosting is that it means that you need to have the debugger connected. So it's obviously not going to be the case once you've got your final product produced and running in the field on a piece of standalone hardware. So in that case, we'd just choose a C project, and in that case, if you want to do printfs, you've effectively got to provide the bottom end of the hardware, drivers to actually display that printf code somewhere like on your LCD screen.
Can you change the nature of the project?
Yes, so thank you for leading me straight onto my next thing. So if you give me 2 seconds and we'll show you how you do that. So if I choose a semi-hosting project to start with, so I'll just call this LPC13 Hello. I click on Next. It then asks me to choose which MCU I want to use. So do you want to move? There are a few seats down the front and on the left hand side if you want to try and grab a seat. Okay, so we can go off and choose the MCU that I'm using. So as I said, this LPCXpresso board is a 1343. So that's selected. And then I come to the bit which says use CMSys peripheral header files and initialization code. So that relates to the code and header files that are in the CMSys project that I just imported. So in this case, I'm going to tick yes and click on finish. And basically that will run a wizard which will then create the appropriate project with all the appropriate settings done. Okay, so that was created as a semi-hosting project. Let's say I've reached a point in my development where I no longer want it to be semi-hosting. I can go down to the quick settings and go to the set library type and change it from redlib semi-host, which is what we've created it as, to redlib non, which basically means there's no semi-hosting support there at all. So it's nice and simple to change that over.
It'd be nice if there's a tooltip that explained what was going on.
Yes, there isn't, is there? Okay, anyway. But that's how we change it, and there is docs that talk about how to go about doing that. So we've created a project, we've imported some projects, a few more bits and pieces now about actually how those projects are set up. So one important thing to note about the way we actually create projects is that we actually create projects with 2 what are called build configurations. So a build configuration is basically a set of options that the codes our project will be built using. And by default we provide 2 build configurations. One called debug. So basically this is a set of options which expect us to be debugging our code, so it's built without optimizations turned on, and that should give us the best possible debug view, but it does mean that our code might be a little bit bigger than otherwise. And we also have a release build configuration. So this is basically built to try and produce the smallest possible code. So we can change a particular project setting so that it's been built for either debug or release quite easily. So I select my project, and if you go down to the quick start panel down here, you will notice that actually the text in here reflects the actual project that I've got highlighted at the current time, and in brackets it tells us that we're going to build the debug variant of that. If I go up and choose release, you will see that the quick start panel updates to show us that we're actually now going to do the release build. Now typically when you do this, you actually want to do it for all of the projects that are in your current workspace, so that everything is being built debug or everything is being built release. So what we do is we can go and just go into the Project Explorer view, Control A to select everything, and then again go and select release build, and everything's being updated to release, and vice versa we can change it back to debug. Okay. Now, let's say that we want to actually take a little bit more control over how our project has actually been built. So rather than just being built as a debug build or a release build, we can change the configuration of how that project will actually be built. So I do that by launching the project properties, which I can do either through project properties, or I can right click over the actual project name and choose properties, or I can use that shortcut I showed you earlier on and control click on the project the MCU down the bottom right hand side, and then I've launched my project properties. So that's launched it up in the MCU settings. I actually want the tool settings, so I just click on the settings there, and then basically we've got all of the various settings for each of the various tools that are being used to build the project. So the C compiler, the assembler, and the linker. So let's say that I wanted to change the optimization that was being built at. I can go and use the drop down box to select turn optimization onto 01 or whatever setting I actually want, for example, and that's actually updating the project properties for the debug configuration. Okay, if I go and choose the configuration I want to change to release, it actually updates and shows me what those configurations are for that particular build. So in this case you can actually see that I'm using a optimization flag -OS to produce the smallest possible code size. So you can go through each of the various settings and change them if you want. I'm not going to do that here, it would take all day. Okay, now one thing I will show you though is that it's possible to change settings both at the project level that we've just seen, but I can also do it at the source level if I want. So let's say I want to actually change that file there, so that compiles for OSpace. I go down to properties, and it just shows me the properties related to how I build that file. So just the C compiler. I can go into the optimization flags and go -OS, click on OK. And if you noticed, if you were quick, you might have noticed that the actual icon changed up here to actually indicate that that file is now being built with a modified set of properties compared to the rest of the project. So it has given you some indication as to what's going on. Okay, so
Can you make that one file go back to the default?
yeah, I mean what I'd normally do is go back there and go that. I mean personally when I do this I don't actually tend to change at the file basis. What I do is I will actually create a subdirectory and place the files that I want to have particular optimization levels that are different to everything else into that subdirectory, and then when I no longer want them to actually be built with that strange set of options, drag them out of the one subdirectory back into the other one, and then it's actually much more visible as to what's actually going on. And again, in that case, you'll actually see the subdirectory icon change subtly to show that the project subdirectory settings have been changed. Okay? Yes, sir?
So when you're done with development and say you want to publish source code, is there an option to export an Eclipse project to a more batch-oriented standard makefile?
So, I mean, underneath the project wizard effectively, you're driving all this through the GUI. When you click build, a makefile is created from the actual settings that you've been using. So there's nothing to stop you taking that makefile and moving it off somewhere else if that's what you wanted to do. It's also possible to build the projects from the command line as well. So we provide a tool that allows you to build your project without firing up the IDE, if that's more appropriate for whatever you're actually trying to do. Okay?
But if I want to give it to somebody to say, this was my source, this was my project, compile it, make sure it makes the right thing,
yeah,
and then go from there. I can do that.
So you can export projects. You can check your projects into Subversion if you download the appropriate plugin. You can check them into CVS if the CVS support is built in. So, I mean, there are multiple ways of getting your projects out of there, and effectively it can do whatever you want it to on that front.
So it could be a deliverable to the client?
Yeah, and I mean LPCXpresso, the tool, is free. So there's nothing to stop the client downloading it as well. So, you know, and using then exactly the same tools that you've been using. So what I'm going to do finally on this little section is click build. So as I said earlier on, basically the build information goes into the console down here or up here. So we can actually see what commands are being used to build each file, and then the linker is being run here. And then finally we've got this post-build step down here. So what the post-build step is doing is basically running a set of commands that we might want to run at the end of our build. And in this case it's run a command called size. So there's size. Okay, and what size does is basically dump out the information about how big our application actually is. So effectively, in this particular case, my code and data, which is what ends up in my RAM, well, sorry, my flash, is 12K as near as anything. And my data plus my BSS, which is what ends up in my RAM, is 340 bytes. So it's actually giving you a quick summary of your flash and your RAM requirements for this particular application. Okay. Now, because I did a build all, there's actually a console view for each one of those projects here. So if I flick to SysTick, we get the build log for SysTick. If I click to SysTick Twinkle, I'll get the build log for that one. Okay. Now let's say I've actually got a problem in one of my example bits of code. So in this case, I'm going to launch SysTick, open SysTick I should say, and I'm going to break it. So how shall I break it? Well, let's very simply take that out. Okay, and what I'll do now is build it again. So I've just removed one of the opening braces, and we've got a number of things I've highlighted on there. So we've got errors, but more importantly, if I go to my problems box, it tells me I've now got 13 errors, and it tells me where they all are. So I can click on that and it takes me to the line, click on that one, click on that one, and so on. So this is giving you your the build log tells you the instructions that were run to build. The problems view then gives you your linkage to actually go back and fix any bugs, errors that were actually as part of that build. Okay. So in this particular case, that is again Eclipse standard. Okay. So what I will do is I will very quickly go back and fix that, because otherwise the next part of the demo won't work. So this time I fixed it, and all of my error messages have gone away. So that's effectively the end of the project creation section of the talk. Now, having built my project, I obviously now want to run it. So what I'm going to do is take my LPCXpresso board and plug it into the USB port, and then I'm going to try and dangle this over the front. Whether this is going to work.
Hang it from the microphone.
There we go. And let's just hope that that USB connection is tight enough to take the weight for a few minutes. So, I've built my project. Obviously, the next thing I want to do is debug it. Now, how am I going to do that? Well, the way to do that inside LPCXpresso is quite simply to go and click on the debug icon in the Quick Start panel, which has also got a corresponding debug button on the icon bar. Now, the reason I say that's the way to do it is because if you go and try and use some of the standard Eclipse mechanisms for actually creating a debug session, it means you need to go and set up rather a lot of configuration stuff yourself. It's quite easy to get wrong. So basically the debug button sets all of the various launch configurations up, it programs your code into Flash, and it's all done automatically. So I will click on debug and then cross my fingers. So basically LPCXpresso is starting, and what it actually does as part of that startup routine to start with is on the LPCXpresso board, if you remember, David said there are two sections. So we've got the debug link, so LPC link, and we've then got the MCU target. And one of the things that the launch configuration will do is basically program up over DFU the debug code into the MCU that's actually in part of the LPC link. Okay, so normally it takes a little bit shorter amount of time to launch than it does the first. So the first time takes a little bit longer than the rest of your launches will actually take. Okay, so what that's done then is it's created a launch configuration, loaded the LPC Link software into the LPC Link hardware. It's set a temporary breakpoint on the start of the main function. It's then reset the board, and that breakpoint is then hit, and we end up at the start of main. Oops. Okay. So, sorry, my driving is a bit awkward because one, the screen's a bit of a funny size, and I've only got about 3 inches to move my mouse. So we've still got the develop perspective. So the develop perspective is a perspective that we developed, if you'll pardon the pun, as part of the LPCXpresso project, which gave you a combined project creation and project debugging mechanism. In standard Eclipse, you would normally use 2 separate perspectives, the C perspective and the debug perspective, to carry out those 2 separate tasks. But what we've done in Expresso is merge the 2 together. However, when you launch a debug session, the develop perspective does change very subtly in that we gain a new view, the debug view, which is this one on the top right here. So basically the debug view is where we control the execution of our program from, okay? And typically that's done using a number of icons. So we'll see these up here. I'll talk about those in a little bit more detail in a minute. We've also got a number of other views that come to the forefront when we're actually debugging. So we have a core registers view, which lists the registers that are actually on our target and their values. We have a peripherals view, which gives us a view down onto our peripherals, surprisingly enough. We've got the variables view and the breakpoints view. Okay, so we'll see each of these in action as we actually carry on through the demonstration. Now the edit view carries on being effectively exactly the same as before, but one thing to notice is that we now have a green bar here highlighting where we actually are in our application's execution. We can also do other interesting things inside here. So for example, if I hover over one of my variables, it tells us what the value of that variable is. I can go and double click in the sidebar and set a breakpoint. So if I open up the breakpoints view, that shows me where my breakpoints are. So as I add a new breakpoint, you'll see it appear and disappear. And I can also go into the breakpoints window and actually temporarily disable that breakpoint if for some reason I don't want to delete it, but I don't want it being hit at the moment. So I'll just go and tick that, and it then, you can see the colour of it hopefully changed in the editor view. But if I go and tick it again, it comes back to the forefront. Okay. Now I said that program execution is controlled through this debug view. So if we look at some of the icons we've actually got up here, we've first of all got restart. So basically this says reload the program, go and hit that temporary breakpoint at the start of main. We've got continue or resume, which basically means go. We've got suspend, which obviously means pause. We've got terminate, which basically stops the current debug session. So it closes down the debug session. We go back to the standard, if you like, project creation mode. We've then got step into, step over, step return. Hopefully, if you're all familiar with using debuggers, the principles are all fairly obvious. And we've also got the instruction stepping mode icon, which is another very useful one. So if I toggle that icon, you'll see that what appears is a disassembly view. Okay, so it's actually done 2 things. It's first of all opened up the disassembly view because it wasn't currently open, but it's also changed the mode that we're actually now executing in. So if I step now, I will step a single instruction. So you can see that the instruction, the green line in the disassembly view, moved down 1. The green line in the editor view stayed in the same place because we're still executing the same source file. If I untoggle the instruction view, I go back to source level stepping. So if I step now, I'll step to the next source level statement. Okay. So we can swap between the 2 very simply just by using that icon there. Now, what I'm going to do now is hit continue or resume. And hopefully, if you squint very hard, you'll see the LED is now blinking. and it's actually blinking at a increasing and then decreasing rate. So hence the name Twinkle was the best I could come up with for that. So it's still twinkling, yeah. So I'm going to pause it. Okay, and that then highlights some more functionality here. So again, this is one of the things we've tweaked inside Eclipse. So the register view that we've got up here, you can see that all of our some of the registers have actually changed colour to yellow. So we've actually highlighted the registers that have updated since the last time we paused. So you can easily see what has changed. Okay. If I go into the variables view, we've now also got a couple of variables being displayed. So these are locals within the function delay, which is where we are at the moment. So we can see our stack frame as well inside the debug view. So I can actually move up and down the stack frame if I want to by just clicking on the appropriate function name. And you can see when I did that, my two local variables in delay went out of scope, so they're no longer being displayed inside the variables view. I can quite happy go and add in my global variables if I want to. So let's just tick a couple. And those two will then appear in there. If I click go again and then pause, the globals will update to tell us basically they've gone yellow to show that they've changed. The locals, however, because they're stack based, you can't do that level of checking. So you'll never see the locals go yellow. You will see your globals go yellow when they change between pausing. Okay, so that's basic debugging. We've looked at the register view. The other interesting thing is the peripherals view. Do you mind going and getting the tickets? So on each of our MCUs that we might be debugging, there are obviously a series of peripherals. Now you can quite easily go and open a memory view if you want to onto the appropriate address and look at the bit pattern, but it's actually much easier to actually view them in the peripheral view. Again, this is functionality that we add into Eclipse. So if we open up GPIO 0, and I'll just close the disassembly view and scroll that up a bit. I'm sorry about this, the resolution of the screen because we're projecting is a bit low. But our GPIO 0 peripheral has been selected, and I happen to know that bit 7 of that is the LED. So is the LED off at the moment? Hopefully it is. So if I enter 1 in there to turn it on, has the LED gone on? Yes. Yes? Wow, isn't that exciting? If I 0 it again, it goes off again. Okay. David, don't want to collect them in. We don't want to collect them in. No, we just want the ones from out the guy at the back. So he's got a reel of tickets. I need the reel of tickets, so can you give people their tickets back? Yeah. Yeah. It's all right, we're coming to the exciting bit with the tickets in a minute. Yeah. So I can quite happily go up and open up various other peripherals if I want. So NVIC is the Cortex M3's vectored interrupt controller. And there's a whole raft of peripherals in there. I can go and open them up and view their contents quite easily. And it sort of breaks all of the peripherals up so we can actually see what bits are much more easily. Now obviously I also want the ability to access memory. So I'll go and open up address, there we go, which on this particular MCU is the start of RAM. And it will then show me the memory at the start of RAM. So by default it lays it out in words. I can go and change the cell size if I want to say bytes. I can change, thank you, sorry. I can change the width, the actual number of columns that are being displayed and so on. So basically you can manipulate this to your heart's content. Right, well let's call it a day on the presentation then. Thank you very much for your attendance and your interest. Thank you.